As a kid, I was really inspired by the explorers. I grew up in Seattle, and Lewis and Clark were kind of heroes locally. And I wanted to be an explorer when I grew up. It was an electric.
So now what would you say machine learning is? And does it differ from your previous definition? Or how does it differ from like the programming you know? It learns the way we learn, right? I mean, it uses, somebody comes up to you and says, see these 5 things, these are oranges, these are apples. And you go, oh, yeah, I guess they do look different. And you know, you kind of get taught, and we're gonna go through that process today. And that's what I wanna do today, because it's gonna seem kind of simple and kind of obvious, but the process we're gonna do here shortly is the process that the machines, hopefully the process you guys naturally do is the process that I want you guys to, it's the same as the machine learning process. So, go ahead.
I was gonna say, that's where the I don't understand part comes in, right? Because there's a level of magic in machine learning at this level, right? Because we talk about, okay, we're gonna show the computer 200 pictures, and the computer is going to learn to recognize an image from those 200 pictures. Awesome. How does the computer learn to map out the important pieces of information in that picture so that we can, you know, identify?
Oh, cool. It's so cool, and I'll show you on a very basic, and that's the example that I want to show you next. So let's look at this student information sheet. I'm gonna let's look at this. And let me, normally what I do is I ask my students, what do you need to know? And I'll ask you guys, and I kind of give you the answers here already, but before I even show them the sheet, and I should have asked you this already, but it's 4:28, I want to get through this. When you guys go to value a house, what do you need to know to value a house?
How much houses cost around it.
Okay, but what data do you look at from those houses? Like, what do you ask? Like, if you were going to go look at a specific house, you wouldn't just say, oh, well, this house is $500,000. Wouldn't you want to know some specific things about that house?
Square feet, number
Yeah,
of
there's zip code.
number of bathrooms, zip code. Yeah, that's good.
Yeah, square feet.
Does it have a lawn?
Yeah.
Yeah.
Acreage.
So here's my task for you guys, and I went ahead and gave you this Google Sheet so that you don't have to calculate by hand. So the things that make up a model, we're going to try and create a model that predicts the house price. In column A over here, I actually have the actual house price. We call that labeled data. So some part of this too is just getting you guys used to the vocabulary we're going to use. But basically it's an example where I tell you the answer. But you're going to use some shape and form of the rest of these columns to come up with some kind of model to predict the house price. So column A is the actual answer. But what I want you to do, not using column A, is to see how close you can come to, no matter what the inputs are, to actually do a prediction. So I gave you the spreadsheet if you want it. The next thing is, once you come up with that model, I gave you 5 totally different houses over here. And you can use your model to create a prediction. All you can use is bedrooms, bathrooms, square feet, house type, address, and city. So put your prediction over here, and one of the important things and we talk about this as well, and one of the important things is we need to decide how close we are when we do a guess. So what's an easy way? Like if I went ahead and guessed, I don't know. I don't know if you guys can see this. Let me make it a little bit bigger. Make it a little small. There we go. Can you guys see that? $460,000?
Barely.
Okay, sorry. Doesn't matter. I'll make it bigger over here. Okay. Let me open it up. I'm just setting you guys up, and I'm going to let you guys loose for like 10 minutes. But I want you to understand the spreadsheet because it is helpful. And I do spend a little bit more time with my students on this. So let's say I made a guess of $460,000, but the actual price was $337,000. How would you guys figure out how close you were? What's an easy way?
Subtract your price.
Subtract it, right? But in the statistics world, we actually want to like penalize if you're further away. I want to like penalize it even more. So what's a common thing that we can use? What's statistically, and the kids have all seen, most of the kids I deal with are juniors, so they've actually seen this in math. One of the things we use is it's mean squared error. So we're going to take our actual and minus our prediction, and we're going to square it. So the further away it is, we're going to penalize it more. And it's going to all be positive. So it doesn't matter whether our guess is too low or too high. That's another nice thing about this. So we need to have, it's called a cost function, but we need to say, what's the cost? How wrong are we when we make a prediction? And then we're going to want to pick the model that the cost is the lowest. Does that make sense? We just want to make, and the perfect cost is when our actual is our prediction and the cost is going to be 0. Because A minus P, our actual minus our prediction will be 0. And we're going to take all of our costs and we're going to add them all up. But what I want you guys to do, and can I break you guys into groups? What should we do? You guys want to try doing it individually?
No.
That's no fun.
Okay, so I'll break both of you guys up into groups. Do you want to do breakout rooms and let you guys talk for like 10 minutes? Is that okay?
We can do that.
All right.
Math is way above I don't.
Most of the formula is already in there, right?
Yeah, some of the formulas are in there.
You come up with the formula. You need to come up with the formula to predict the house price. That's what I want you guys to do. I want you guys to take these fields. You can take one field, you can take multiple fields, and use them somehow.
Square feet times 5/7 divided by number of bedrooms times.
Yes.
Can we use the column A to help establish?
No. You can use it. You can use it for the cost function, right? So you can do column A minus your prediction to see what that gives you, and then change your prediction. And you can do it for multiple houses, and you can sum up all of your costs for each. Like say you do it for 5 houses, you can then do your cost for each house, square it, add them all up, and then maybe tweak your model and see if you get lower costs.
Well, I'm just thinking that I don't have any theory of how much a bedroom was worth or how much.
I know. That's why it's fun.
So if I use,
that's why you jump in there and you start putting numbers in. And that's why I gave you the spreadsheet, so it makes it a little easier. You don't have to do all this.
Make something up and see if it gets close.
That's exactly.
Wait, this one more? Should I add this? Should I multiply that? Oh my goodness.
And in the machine learning world, we take a guess at the beginning and it's not right. And there's a way using derivatives, there's actually a way to make it right. It's really cool. And I actually taught that lesson today. It's called gradient descent. But the big thing is the process of make a guess, make some changes, see if you're closer, then make some more changes, see if you're closer, and then see if you can come up with a model in, 10 minutes. And you're not going to be exactly right, but we're going to try and get close. What did you guys do?
A lot of guessing.
Okay, no, just tell me your process. Mary, tell me your process. Oh, wait, you're muted. And I do that every class all the time. It's horrible. Still can't hear you. Unmute.
Muted. There we go.
There we go.
I'm so used to Google Meet with my students.
No, I'm with you.
We started with just sorting by the main categories and then started plugging in some formulas and then just started adjusting.
So what, when you said plugging in your formulas, like
into one of the cells on the right, just said,
but what, how did you make your formula?
Like the first thing we said was we just went, I think we went like, you know, number of bedrooms times number of bathrooms times this, and then started dividing to try to make it smaller, and just really we're just playing around with what factor could we make this, but you know, we ran out of time.
But no, so like what was your ending equation?
We were at something like, well, we started with, we had something at first that was like, you know, oh wow, why did we use the price? So first we had, that's really wrong. I thought we were doing bedrooms times bathrooms. So first we had like price times bedrooms times a percent of the square feet. And I think we thought we were doing bedrooms times bathrooms. We ended up doing 2 times bedrooms times bathrooms and trying to factor in the square feet somehow. But then we said, let's graph it and look at the relationship.
Right. And that's one of the things you do, by the way. So 2 times bedrooms and then and bathrooms?
Yeah, 2 times bedrooms times bathrooms. And then we started trying to factor in the square feet a little bit, but that wasn't quite giving us the big enough number. Oh, it was amazing to see how that, whatever you called it, the mean squared error, how huge that was when we didn't think we were off by that much.
Right? I mean, you really get penalized. Okay,
Yeah.
So that's a really good point. Dave, how about you and your group? What'd you guys end up with?
Well, we tried to create a ratio for bedrooms to bathrooms. We assigned numeric values to house type. So like a condo
Oh, that's
is
good.
worth 2, detached was worth, well, we put detached as the highest, but I've
Yeah.
started messing with that number.
Did you multiply it by anything?
Yeah, then we multiplied everything together, basically. We multiplied square feet times house type times bedroom, and we used a fixed per square foot price. We started with $100,
That's
then we
good.
went to 75, and I've been playing with that number.
Well, we started with 1,000, and then the price of the house was
It was $1 million.
it was a couple million. So
Way out of our price range, our price point.
we were wrong.
Okay, so you made a guess. It was crazy and wrong. How did you know how to guess the right? How'd you know how to change your model?
Well, we used your what's it called, mean square error and the differential.
Yeah.
And so I'm looking at the mean square error, and you know, I'm trying to get it closer. I'm trying to reduce that number. I'm trying to reduce the differential, but to the lowest number and be consistent about it. Right? Like, I think the value of 2 for the condo seemed to work, because that got us really close with almost all of the condos consistently.
That's great.
But the other numbers didn't work at all for detached homes or the townhomes. So that means that I need something else to change. So like right now I'm sitting here changing. So instead of doing bedrooms over bathrooms, I'm doing bathrooms over bedrooms. But now the numbers are all, you know.
Okay, so let me convert kind of what you said into machine learning language. So one of the things you did was you had features. You decided which features you wanted to use, square foot. You created a new feature by using 2 other features, and we do that sometimes, using bed divided by bath. You converted a non-numerical feature to a number, which we do a lot. Like, you're going to have to do that with vision, but we know we can, like with images, we can convert those to numbers, right? Can't you convert like grayscale, or you can actually convert them to colors as well as grayscale? So one of the things we have to do is we have to convert things to numbers, not all the time, but a lot of times. Then you did this 75 times square feet. We call those weights.
Yeah.
So we have some number times the feature, and you change the weights, right? You started messing around with this 75. So you started trying to change the weights to minimize the mean squared error. That's what you tried to do. That's what linear regression is, and that's what very basic mean squared error is you're changing, you figure out some features, you multiply those features by a weight, and you add them up, so you have some kind of weight 1 times feature 1. So you might have weight 1 times number of bedrooms, right? And then you'll add weight 2 times, I don't know, square feet. And you keep doing that, and you're going to end up with some kind of prediction. You compare it to your actual, square it with mean squared error. You have some kind of cost function, and then you try to minimize the cost function. That's it. That's machine learning, and you do it with lots of data, and you do it over and over and over again. Now, we have 5 minutes. So one of the things, I do want to show you this because I think it's really cool. And I know this is probably going to blow your mind, but can I tell you how we use, just real quick, because how much do you guys know calculus? Are you guys?
It's been years.
None.
Years.
Okay.
Guided Taylor equations, okay?
Can I
know it exists.
can you pin, let me stop sharing. Because I do want to show this on the whiteboard, because this is the magic of machine learning, and it's so freaking cool. It's a lesson I taught today, and it blows the kids' minds. Can you pin my screen?
Yeah. And you can pin
And we can pin it individually if we want
Spotlight.
to.
Yeah, can you just pin my screen real quick? Because I do want to show, because you were talking about this, Dave, and you wanted to know about the magic. Can you see me?
Yeah.
Okay. So it's funny because as you were talking, I started writing down in machine language the stuff you were doing. You chose some features. Some you made sure you converted them to numbers. You chose some weights, 75, for example, for whatever. You pick some random weight. You make a prediction, you calculate the error, then you change the weights. Coolest thing like ever. What's the shape? You guys know the shape of that graph?
That's the parabola.
What's the shape of x squared?
And you.
Right, it's just a parabola, right? What's the shape of your prediction? What's the shape of a cost function? It's just a parabola. And guess what our x is? Our x is just the weights down here. And this is our cost. So what do we want to minimize? We want to come down here and find, the local minima is the global minima, which is really cool. So we make a guess of a weight, say it's 75 and it's up here. I need to go this way. Guess what I do? I find the derivative. The derivative is positive, I subtract it, and I make my next guess over here. Guess what my derivative is? It's negative. I subtract it. It makes me go here.
Oh
So
my gosh.
derivative to guess and keep getting closer, and that's the magic of machine learning. It's so freaking cool. It makes me shiver every time. And
You're gonna make me take linear algebra classes.
you want to know the other coolest thing about it? This derivative right here is bigger than this one. So I'm going to take bigger steps back towards my answer if I'm further away. And when I get closer, this is flatter. My derivative, right? The slope, the tangent line is flatter. It's smaller. So as I get closer and closer, I naturally start taking smaller steps. This is the magic, dude. It's so cool.
That's very cool.
What I wish I understood, but I did. I mean,
That's very cool.
like I know.
I get what, yeah, it's just that the programming behind that,
it's not that bad. And actually, the derivative, the partial derivative, is really simple.
Wow.
And the code using NumPy is 4 lines of code
Oh my gosh.
to calculate.
That's
calculate.
wild.
I was just looking, it's 4 lines because it does it's all these matrices, right? But it does get a little funky and it blows your mind, but you wanted to know the magic. That's the magic.
Wow, that's pretty cool.
And it's really cool.
That's pretty cool.
And you go, it's so simple. Really? That's all they're doing is subtract. I don't know if you guys have heard back propagation. All that is calculating the derivative and
Oh my
you have all
God.
these things and it's just back propagating the derivative backwards through all these. But that's all it's doing. It's all about the
So
derivative.
cool.
And the derivative makes you make the change in the right direction, and it makes it smaller the closer you get to the right answer. It's cool.
Wow.
Yeah,
Wow.
really cool. Today, because I was teaching them the gradient descent, they need to take a guess based off of these weights, and they need to see the cost graph. So I had them basically calculate what the cost was and then graph it. Then they had to hand calculate it. Then they had to graph it and see where it was. And then so we kept going back and forth between the math, the hand calculation, the graphing. And I could see how they were hand calculating and see if they were doing it right. So it works out. I like it because you can see them type live and they can't see each other's stuff. So yeah, I use it a lot.
And that's for a math class.
Yeah, it rocks for math, right? But I mean, I'm kind of hacking it for computer science. So this is an example of how I would use it. So we did a phonetics lab. I teach APCS too. And we did a phonetics lab. So I had them basically sketch out their code for me. And so this was pieces. These were helper methods. And I wanted to kind of piece it together for them. And then the kids just start typing and I can see as they type, which is really sweet. So I put them in breakout rooms. And then if some kids are struggling, I go to the breakout room where they're struggling. And it's to make these, I don't know if you guys are familiar with Desmos. Usually if you teach math, you're familiar with Desmos, but if you haven't, you're really not. But it's sweet. They're really easy to create. Like it takes 5 minutes to create them. So